Okay, folks, so we're going to start a new topic today, a physics topic, and this is our learning intention. So there's a number of things that we're going to learn today. So we're going to figure out the different types of energy that exist. We're going to talk about energy transfers that happen, and that's essentially any type of technology or appliance that you use. There's energy transfers in those, and we're going to talk about sources of energy in nature. Before we get into it, I am going to refer you to this statement from our rag sheet. So by the time we get to the end of this topic, you are going to have to design, build, and test a particular device that transforms energy from one source to another. And that device has to have a particular job, so a function. You have to be able to describe the energy changes and describe ways to improve efficiency. So I may be able to help you with in terms of bits of kit, and hopefully we'll be back in school, but it may be that you are designing and building it out of cardboard and we're just labeling it all up. And if I can then supply some things like solar panels or wires or whatever it is you might need, you may be able to build it in lesson and to test it. So have a think now as we go through this about what devices that you could make that might have a particular function, because that's where we're going to at the end. Now, if we were in lesson, I would be showing you this. This is not my house, but once upon a time I had one of these balls. And I want you to tell me what are the different types of energy that you will see. Now, I think if I play the volume on this, you will... So we could watch that all day long, but what are the types of energies that you might have observed with this particular ball? So firstly, the ball moves, so that there's a word that goes with moving energy. We can see the fact that there's lights there, the fact that there was sound we heard, and it's then the energy that actually makes it move, and how does that energy actually get transferred. So there's quite a number of different energy sources there, but we'll go into a little bit more detail. So I've asked you already to either have printed this out or to have put a version of it into your notebook so that we can go through it. Now, the first thing we have to understand is what is energy. And we're doing physics, and physics isn't always very logical. So you might think, well, I eat chocolate bars to get energy, and what does that do for you? Well, actually that makes you move, it makes your blood flow, and things like this. So in energy speak, or in physics speak, energy is the ability to do work. Now, this is not work as in get up at night for your 9-to-5 job. This is work in terms of it means to move something. So work is essentially force by distance. So how much effort do you have to go into moving something? And that applies even for you having to stand up. That is doing work. We measure it in joules, is the energy unit. And here's a question: does energy have a mass and take up space? So what do you think? And the answer to that is no. Energy doesn't have mass and it doesn't take up space. So mass and space refers to really matter. So energy is not one of the three states of matter. It is something different entirely. Okay, so ability to do work. Now, there are two groups of energy that we're going to talk about today, and you can see it in your table. We have the idea of what's called stored energy and moving energy, and there's 9 energy sources, and they fit into one of those two categories. And you already have the headers. Now, if we were in school, I'd be giving out 10 envelopes, and we'd be doing a little bit like the Oscars. Somebody would call out what they have in their envelope, and they describe their picture, and we'd make a decision about which of the energy headings, types of energy, would we call it. So we don't have 10 envelopes. We do have 10 pictures though, and we're not matching today. But as we go through it, you're going to decide, is it a stored energy or is it moving energy? And you're going to maybe use the example. And if in doubt, we leave it till the end and we will check through it. So first one, We have a picture of the nuclear power plant in the symptoms, energy from the nucleus of an atom. And you have to decide now what type of energy is that, and is it stored or is it moving? The next we're going to look at is energy from magnets. So which type of energy is this, and is it stored or is it moving energy? Next one is energy we hear. So what is the type of energy? And decide, is it stored or is it moving? Now, if you are confident that you know what they are, you can use these as your examples. So our next one, energy from objects that are up high or changed in shape. So what do I mean by the change in shape? Well, if you were to get an elastic band and if you were to like hold it and pull it back, that is a change in shape. So this one might be a little bit difficult. So again, decide what type of energy if you can, and the type, is it stored or is it moving energy? The next one is energy from things we plug in. So specifically, if it's plugged in, it has a very specific type of energy. So again, stored or moving. And last thing, it would make air warmer. So now there's a posh word for this type of energy, and I think I've used both on the sheet. And again, decide, is that stored energy or is it moving energy? So the next one then is energy from objects that are moving. And again, there is a posh word to describe moving energy. So straight away that fits into the moving energy category, but it's what's the word to describe energy that's moving. The next one then is energy from the sun, and it obviously will make plants grow. So is that energy moving energy or is it stored energy? Now the last two, these are the two that are the exact same. So energy from food and makes organisms grow versus energy from a reaction and makes equipment work. These are both the same types of energy, and you have to decide, is it moving or is it storage? Now, I have put a link for this in your assignment. It's under types of energy, so if you're not sure, please have a play of this, and it might do some explaining for you. We're not going to play it now. So we're going to look at the ones that were the stored energy, and we're going to start with the one that's possibly the hardest to do. So types of energy that is in a stretched elastic band, is in a spring, is in a wound up clock, and this is the joke that goes with it. So this is called potential energy, and the way I think about all of these things is if someone has the stretched elastic band and it's aiming at you, and if they let it go, potentially it's going to hurt if it hits you. So energy that's usually up high, so top of a roof, and you're going to throw it off the roof. Before you throw it off the roof, it has what's called potential energy. And all of both the stretched elastic band and the person at the top of the roof, they are also, can be called gravitational energy, because the thing they're going to do once they start moving is they're going to go down. So if you're storing anything at a height, or if you are stretching it, that is what's called potential energy. And I always think of it, as I say, in terms of if I was to jump off a roof, well, potentially I am going to die. I may be very lucky and hit a lovely trampoline and be safe. Or if someone's going to aim this stretched elastic band at me, well then potentially it is going to hurt if it hits me. So that is a stored energy because it hasn't been used yet. It's stored in the elastic band, or it's stored as you stand at the top of the roof. The other ones for storage are the ones that are in the nucleus of your atom. So that was nuclear energy. And obviously the energy there is stored, and we use that to generate heat, and use that to generate electricity. So then we have energy that's in petrol, in timber, in coal, in oil, in food, in batteries. These are all the same types, and they are what are called chemical energy. So same type of energy is in food, and same type of energy that's in fully charged batteries. They're all chemical energy. Okay, and these are all stored energy because you eat and then you move. So you turn the storage energy into movement energy. In terms of our moving energy ones, well then it's the speeding train or falling rocks. So once you get any type of movement, we have this posh word to describe moving energy, and it's called kinetic. Now there are some watches that you can buy and you wear them on your wrist, and you never have to wind them because they wind themselves every time you move your hand. So kinetic energy is just the posh word for moving. So type of energy in water particles, they are heated. So heat energy, you can call it, but I like to use the posh word, and the posh word is thermal energy. So if you have thermal underwear, that's going to keep you warm, and we now have our different types of tops that will either keep you warm or cool you down. The type of energy that helps plants to grow is solar energy, or occasionally it can be written as light energy. And the type of energy we hear is easy, that's sound, so it's all moving. These are all moving energies. Energies comes from things we plug in, so as soon as there are wires involved, doesn't matter what we're talking about, there is electrical energy, has to be there. So if initially it's coming from a battery pack, that is fine, but it's once you have any wires involved, that is electrical energy. And then magnets is magnetic energy. So you've hopefully seen magnets and iron filings. They pull the iron filings to them. That is moving energy. So kinetic is the posh word for moving up at the top. And we have our posh word thermal. Solar means light. And again, all of these are moving energies. Now, we have to do one of the laws of physics, and it's called the principle of conservation of energy. So what does that mean? What things do we know in that sentence? So you may have heard conservation of energy or conserving energy. And what does that mean? So for conserving energy, we're saving energy and we're not wasting it. And usually it's in our houses is a big thing where we talk about conservation of energies. So we do a whole load of different things, and you will have a whole load of different things in your house that are going to conserve energy, and that's going to save your parents money. So it may be something like lagging jackets on your hot water tank. You might have your attic insulated, use draft excluders, fill the air cavities in your walls, double or triple glazed windows, carpets, curtains. You might keep your windows closed all the time. You might have thermostats and radiators. You might use aerated appliances. Turn off the power at your sockets. They are all ways of conserving energy. But the principle of conservation of energy is a little bit different to that. So what it means is that energy cannot be created or destroyed, but it's changed from one form to another. So let's have a look at some examples. So you need to have your definition for it, and we're going to now apply it and use it. So what does that mean? So this is mobile phone, and you have to decide by looking at a device, what are the types of energies in there? And once we figure that out, we then divide them into what is the source of the energy, what is the useful energy it gets transferred to, and then what is the dissipated or the wasted energy. And dissipated just means that it's wasted energy, but it could be released into the atmosphere, or it's not useful. So if we look at our mobile phone and we look in terms of the source of energy, well, the source of energy is a battery, and we've said for our batteries that is chemical energy. So that's the stored energy that's in there. Now, what is the useful energy that we want to get from phones? Well, we definitely want light, and we definitely want sound energy, because we'd like to see it and hear it, because that's what we use it for. And then what might be the wasteful energies? So you mightn't see it as much with your phones as used to be, as my son would say, in olden days, but the dissipated and wasted energy can actually be as heat. So thermal energy, that would be the wasted energy. And if you can look at a device and divide it into what's its source, what's useful, and what's the wasted or dissipated energy, then you are applying the conservation law of conservation of energy. So the chemical energy can't be created or destroyed. It can just be changed from one form into another. So the chemical is turning into light, it is turning into sound, and it is turning into thermal energy. And that is the law of principle of conservation of energy. So if we have a look at a lamp, well, what's our source? So again, the source in this case is going to be electrical energy, because it is going to be, there's wires involved. Now there is a chemical source for that electrical energy, so it's either going to be made by burning fossil fuels or burning wood or coal, but as we're looking at this lamp, the source is going to be electrical energy. So what's the useful energy that we want from lamps? So the main useful energy for lamps is going to be light energy. And in terms of wasted, Not so much now, but it will be thermal energy. So some lamps, they will get really, really hot, the light bulbs. So that will be a waste. And some lamps, you can actually hear a buzz out of them. So you might be, sound energy might be your wasted energy. So we're getting, these are our energy changes or our energy transfers. And again, we're applying the principle of conservation of energy. So make sure you have your examples. If we were in school, we'd now be doing our circus and we'd have 9 different devices and you would be trying to figure out what they are. We don't have that luxury because we're not in school, but you can have a listen to this. Again, the link is with the assignment. It's a song and it'll just explain the types of energy and also the principle of conservation of energy if you're still having some problems. So the last bits that we're going to look at today are the sources of energy. So we have just done the types and we have covered the conservation of energy or principle of conservation of energy. And by doing that, we've also looked at energy changes or energy transfers. So you have an idea now from looking at things what the energy is being converted into. So in terms of our sources of energy, the main source of energy that we have is the sun. And actually, if the sun disappears for us, possibly we're technologically proficient enough that we can survive without it, but it has a lot of effects for us. So can you think about what types of energy the sun gives to us? So there's 2 really obvious ones, and there's one that's maybe not so obvious. So the sun, I'm hoping you're saying miss, it gives us light energy and it gives us thermal energy. They're the real obvious ones. So it gives us, when it's facing our part of the planet, gives us daylight, and when it's facing our part of the planet in the summer, it's going to be warmer than it's going to be in winter. And the last one that you may not recognize that it gives us is it actually gives us kinetic energy. So we get the light, which we use in photosynthesis, helps us to see, no complaints there. We've said the heat, and I'd rather you would use the word thermal. It's going to keep us warm. But the kinetic energy it actually supplies us is that it influences and it produces waves and wind for us. And we use these specifically to make electricity. So this one might be the surprising one of the 3. Now, we're going to watch a little bit of Tim and Moby, and then these will be the questions. So what is the energy from the sun called? Which of these energy sources will likely run out eventually? What does a generator do? What type of energy comes from hot rocks in the Earth's crust? Which of these are fossil fuels? What is another name for hydroelectricity? What is burning wood an example of? What happens in nuclear fission? And which of these is not a drawback of fossil fuels? And where do fossil fuels come from? So,
from Abby. Humans use... Dear Tim and Moby, where do we get the power to heat our homes, light up street lamps, and move cars? From Abby. Humans use energy for everything. As a result, we've come up with a lot of ways to generate it. Probably the most basic method of energy production is from burning biomass, like wood and animal droppings. This campfire my dad built is a good example of biomass energy. Biomass energy is used all over the world for cooking, lighting and heating. Now if you're talking about electricity, there are lots of ways to generate that. Most involve a device called a generator. Generators come in tons of shapes and sizes, but basically they all do the same thing. Convert motion energy into electrical energy. Let me explain the basic principle. If you rotate a coil between the poles of a magnet, an electric current flows through the coil as it passes through the magnetic field. Good question. Finding the energy to turn the coils is the real trick. Here's some ways to do it. Hydroelectric power plants generate energy by using water trapped by reservoirs and dams. Water flowing through a small opening in a dam can turn a wheel called a turbine, which is attached to the generator. This will create energy. Hydroelectric energy can also be generated by using the tides in the ocean. At high tide, water is trapped in a reservoir. At low tide, the water is released, turning turbines. Windmills work in a way similar to hydroelectric plants, but they use energy provided by the wind. Both wind and water energy are often used to create mechanical energy as well. Turning gears to pump oil or water out of the ground, or grinding stuff up, or anything really. Next, we have geothermal energy. Geothermal energy comes from hot rocks in the crust of the earth, which can hold temperatures of up to 1,000 degrees Celsius. Water heated by these rocks turns to steam, which then turns the turbines of generators. Solar energy comes from the sun. Heat from the sun can be focused onto pipes of water, creating steam, which turns the turbine of a generator. Solar energy can also be converted directly into electricity with the use of a photovoltaic cell. Now, nuclear reactors are something else. They take advantage of the unstable atoms in substances like uranium and plutonium. And by a process called nuclear fission, they split the nuclei of these atoms and create a controlled chain reaction which generates a lot of heat. And you guessed it, that heat turns the water into steam, which turns the turbines of generators. Lastly, we have fossil fuels. As the name suggests, fossil fuels like coal, oil and natural gas come from the remains of dead animal and plant matter. Fossil fuels are burned, turning water into steam, which turns the turbines. But there are a couple of problems with fossil fuels. Firstly, burning them produces a lot of pollution, as well as carbon dioxide, which contributes to global warming. Secondly, the process that turns a tree into fossil fuel takes millions of years, much longer than it takes us to burn it. So at our present rate of consumption, we'll have run out of fossil fuels in about 300 years. That's why scientists and industries are working hard to develop alternate energy sources, like fuel cells, for example. Fuel cells convert hydrogen and oxygen into water, producing electricity in the process. The only byproducts of the reaction are heat and water. The kinks are still being worked out, but hopefully alternative energy sources will bring us closer to the safe, clean energy sources that humans need so badly. Now look what you've done.
Alrighty. So we've now had a look at the sources of energy. So energy from the sun, I'm hoping you're all shouting at the screen that that's solar energy. Which of these three sources are most likely to run out? I'm hoping you're saying C, fossil fuels. What does a generator do? And it converts motion into electricity. And this is really important, and this might be something that you need to keep remembering now for making our device, because the device you're going to use may be turning motion into electricity in some way. What type of energy comes from hot rocks? This is geothermal. So thermal means heat, and geo is to do with geography, which has to do with the earth. So that might help you figure out what geothermal is. Which of these are fossil fuels? So it's coal, oil and gas. Hydroelectricity. Hydro means water, so usually it's from dams or from tidal. The burning of wood is biomass energy. In nuclear fission, energy is released when your atoms are split apart. Which of these is not a drawback to fossil fuels? I'm presuming it's they taste terrible. I hope no one ever eats any of them. And where do fossil fuels come from? So they're the remains of dead animal and plant matter for millions of years. Now, in terms of our sources of energy, when we talk about them, we have two words to describe them. We have renewable and non-renewable, and you have to be able to tell the difference between them. So if you have to renew your membership for Netflix or whatever it is, that means you have to do it again. So if you have renewable energy, it means it's going to be around again and again. So it's energy that's always available. And one of the bonuses of renewable energies is there are no harmful waste products in terms of pollution or in terms of CO2 as a greenhouse gas, versus non-renewable, which does have its harmful waste products, and they also will eventually run out. So in terms of our sources of energy, what can we say about them to make sure we're happy? So we're going to have to make the decision, are they renewable or non-renewable? And all of these sources of energy, as far as we're concerned, are going to be used to turn turbines and generate electricity. Now, obviously not exclusively, but that is mainly what we do, because electricity is ridiculously useful in terms of what we can do with it. So these sources of energy are the ones that we've gone through. So solar is light energy, and again, the light would heat water, and the water turns into steam. So water into steam, and it's the steam is going to do the turning. So water into steam, and once you have that, you can turn your turbines and generate electricity. And solar energy is obviously renewable. For wind is similar. It's going to turn a turbine directly. So this does it very directly. So it turns the turbine directly. So that's brilliant. And straight away you generate electricity. And wind is also renewable. Wave energy does the same thing. It's going to be used to turn a turbine. And it is obviously renewable. Tidal energy, so this is the scenario where the tide comes in and they hold the water, and then once the tide goes out, they let the water go out. And again, tidal will turn a turbine directly. So this is what makes them good sources. So it's renewable. So biomass is essentially wood, compost, animal droppings. We just use as wood. So for wood here, we'd have to heat water into steam, and that's going to then turn your turbine. And biomass is renewable because we can keep growing trees. So fossil fuels, again, we use them to heat the water into steam, to turn the turbine, generate our electricity. The unfortunate bits for this is that it is non-renewable. So this is our first non-renewable. Geothermal is, I always think of it as hot rocks. So you stick your pipes down into the earth, and that heats water to steam, turns your turbine. Okay, I don't have much room for this. And this is renewable energy because hot rocks will always be there. So hydroelectric is using water in dams essentially. So you hold the water back and then you put it through a hole, and it's going to turn the turbine directly. And it is renewable energy because we can keep trapping the water. It may take you a while to build up the water supply, but technically you can trap it. And the last one is the nuclear energy. And again, the nuclear energy will turn water into steam. So if you watch the Chernobyl documentary, the only issue with nuclear energy is it is non-renewable. Okay, so these are all our sources of energy, and some of these you may be able to use them in your design of your device that has a particular job at a later date. Okay, so again, we'll go back. Sources of energy, they're going to be used to turn turbines and generate electricity, and I'm just going to add in the fact by turning water into steam. Okay, because that is our main big ginormous use for all these different sources of energy. So just then to highlight, why is electrical energy useful? So what's the useful form of energy in irons and kettles? So I'm hoping you're saying thermal. In stereos, it would be sound energy. In light bulbs, it is the light energy. And in washing machines, can we figure out what one that one is? So it is actually the kinetic energy. So that's why electricity is so useful, because we can transfer it into different types of energy. Now, the last thing we're just going to talk about here is what are some ethical issues with electricity generation. Now, we haven't done electricity as in what it is and how it works, but you may be able to think of some issues that we now have with electricity generation. So we've said the word ethical is kind of like, should we do it? But it has data behind it that gives you whether or not we should or should not do it. So you might have some ideas yourself, and I'd love to hear them, but one of the main ones is using fossil fuels and greenhouse gas production. So fossil fuels are non-renewable, so that's not good, and greenhouse gases is global warming, so that is also not good. Other ones might be the idea of we need pylons now to move that electricity that's made in power stations, and that's a visual type of pollution, and we also destroy habitats to generate it, to have these pylons. Nuclear plants generate a huge amount of radioactive waste. We don't use it at all in Ireland, and if there's accidents, well, then you're in big trouble. And the last one is hydroelectric. So you might not be aware of this, but they actually have to flood land to make the dams, the reservoirs, and not only do you displace people, but you also destroy habitats to make them. So there is a worksheet for you to do with a number of questions, and happy St. Patrick's Day.